In the next example, we'll again be drawing index cards, this time from a single box containing 6 index cards. Three of the cards have success written on them. And 3 of the cards have failure written on them. Two cards are drawn, and the number of successes is recorded. Is this a binomial probability experiment? Why or why not? So we have trial 1. We draw a card and note whether it says success or failure. And then in trial 2, we draw a second card and note whether it says success or failure. And so the number of successes in our 2 trials could be 0, 1, or 2. We clearly have a fixed specified number of trials, n equals 2. Next, we need to know that those trials are independent. What do you think? Do you think they're independent? I don't think so. And here's why. So I'm going to say not independent. So to see why this is, in trial 1, the probability of success is 50%, right? Because there's the same number of success cards as failure cards. Now suppose we draw a success card. In trial 1. Now there's 5 cards in the box, 2 of which are success cards. So if I drew a success card, then one of the success cards is gone. So now for trial 2, so then for trial number 2, the probability of success is 2 out of 5. In other words, 0.40, not 0.50. So trial number 1 affected outcome number 2 by changing its probability. So thus, this is not a binomial probability experiment. I've got one more example for you. According to the Red Cross, 7% of U.S. residents have blood type O negative. A random sample of 4 U.S. residents is obtained, and the number of people with blood type O negative is recorded. Is this a binomial probability experiment? Why or why not? First of all, number of trials. The experiment is to sample 4 U.S. residents. So each U.S. resident, each of the 4, is a trial. So N equals 4. That's a fixed, specific number of trials. Now, are these independent? Well, if you think about our last example, it seems like these would not be independent, because suppose our first pick is someone that does have blood type O negative. That means that there's going to be slightly less than 7% of the remaining residents that have blood type O negative. So I'm going to say not really here. But at the same time, think about how many people there are in the United States. I don't know what the number is, but it's a lot of people. If you've selected one person out of that giant population, it really doesn't change the characteristics of the rest of the population very much. So I'm going to say not really, but sort of. And again, that's because the population is so large. So we can go on from there. We need to know that there's 2 mutually exclusive outcomes. And as always, to know what the outcomes are, you should see what's being recorded. Well, what's being recorded is the number of people with type O negative blood. So one outcome is O negative, and since that's what we're recording, that's what success is in this experiment. And the other outcome is not O negative. So that's what would be considered failure. Last, we need to know that the probability of success is the same in each trial. Since 7% of the U.S. residents have this blood type that we're interested in, the probability that when we randomly select a U.S. resident, the probability that they'll have that blood type is 7%, or 0.07. And that's why I put the note here. Remember that the probability of getting a certain characteristic, if you randomly select someone from the population, that probability is the same as the proportion of the population that has that characteristic. And we talked about that in section 2.1. Now that's the probability of success for the first trial. And as we discussed when we were talking about independence, every time you pull someone out of the population, that's going to slightly change the proportion in the remainder of the population, but it's going to change it so slightly that we're going to just say the probability is, yes, 7%, 0.07 for every trial. So we can say that this is a binomial probability experiment. I mean, if you wanted to be really pedantic, you could say this is approximately a binomial probability experiment, but we're just going to consider it as a binomial experiment. And just to summarize all this discussion about the large population, I found something from Statistics for Dummies that I think summarizes it better maybe than I've said it, which is that if the population is very large, for example, all US adults, that probability P, it still changes every time you choose someone, but the change is negligible, so we just don't worry about it. We still say the trials are independent with the same probability of success, P. And as they note, that makes life much easier.